Now we're going to look at how we can express our concentrations of solutions using different units. So first we see this unit of mass percent. So whatever our analyte, whatever A is here, we can take the mass of that in the solution. So this will be the mass of my solute. In grams, say, divided by the total mass of solution, again in the same unit of grams. If I divide one by the other, then multiply by 100, I can obtain the mass percent of whatever that solute is, that A is. So an example here for a 36% HCl by mass solution would contain 36 grams of HCl in 100 grams of solution. So that's the water, the HCl, everything combined, times 100. Right, so that will give us that 36% HCl. If I wanted to find out how much mass of water I have, I could take the 100 grams of solution, right, solution. And then subtract my 36 grams of HCl. So I would see that I have 64 grams of just H2O. So one of our units, molality, that we're going to take a look at a little later, finding just the mass of the solvent can come in handy. Next unit we have here is something called parts per million. So when we find something, it's abbreviated ppm here for parts per million, we'll take the mass, again, of A of our solute, say in grams, we'll divide by the total mass of our solution. And then instead of multiplying by just 100 for a percent, we're going to get a parts per million. So it's times 10 to the sixth. And then say we wanted to find a unit ppb, parts per billion. We use the same type of setup here, mass of A in grams, divided by the mass of our solution in grams, times 10 to the ninth now. And that's because we're measuring in parts per billion. So those are the equations for those. So let's take a look at sample exercise 3 here and see if we can calculate the percent of sodium chloride. So this is what we're looking for, the mass percent of NaCl in a solution which has 150 grams of sodium chloride in 50 grams of water. So when we set this up, we want to make sure that our total mass of solution is going to be a combination of both of these values. So it's actually going to be 51.50 grams instead of just maybe 50. So don't be fooled into thinking it's just 50. So if I want to know my mass percent, so I'll set up mass percent of NaCl. So I'm going to put my mass of NaCl on top, 1.50 grams, divided by 51.50 grams times 100. And this will give us a mass percent of 2.91. So we can take a look here also at sample exercise 4, and we can use the same setup and just rearrange our equation now to solve for what we're asked here. So we want to know what the mass of this compound here, which is sodium hypochlorite, NaOCl. We want to know how much of that is in a bottle, which contains 2.50 kilograms of bleaching solution. So this is the active ingredient in bleach. And we know that it has this mass percent, 3.62. So we could set up our equation to have 3.62 mass percent of NaOCl, right? So equal to the total mass of our solution will be 2.50 kilograms And this would be X kilograms. This is what we want to solve for, the mass up top here. So again, we'll have to rearrange this equation, but we can plug in this mass in grams. So we can change this to 2,500 grams. And then I'm going to multiply 3.62, right? I know that I would have that many grams in 100 grams of solution if I have a 3.62 solution. I could set that equal to my X grams here over NaOCl over my 2,500 grams of solution. So now I would cross multiply these terms, divide by 100, and my final value in grams of NaOCl would be 90.5.